Assalamu alaikum wa rahmatullahi wa barakatuh. Today we discuss a new chapter of Unit 2. This chapter is titled Radioactivity. We have different objectives in this chapter. First, we have to define the radioactivity. Then we should know the types of the radioactive nuclear reactions and their properties. Also, we have to write a nuclear reaction using Soddy's law or by applying the law of conservation. And at the end, we have to define the activity and the half-life of radioactive nucleus. As you know that the elements are made up of molecules that are composed of very tiny particles called atom. Let's remember some idea about the atom. The atom is made up of a nucleus and electron cloud. The nucleus at the center of atom is made up of a proton and they are positively charged, and a neutron and they are neutral. Also in the electronic cloud there is electron and they are negatively charged and they orbit the nucleus. As we know, the atom is symbolized by XZA, where A is the mass number and Z represents the charge number or the number of proton in an atom. Also, each proton or neutron is defined as nucleons, so we can say that A represents the number of nucleons in an atom and it is defined as the sum of Z plus N, where N is the number of neutrons. Let's remember the definition of isotopes. Isotopes of an element are the nuclides having same charge number Z but different mass number A. In other meaning, isotopes have the same number of protons but different number of neutrons. Examples: O16, O17 and O18 are called isotopes since they have the same charge number Z but different mass number A. In the same way, we can say that the uranium-234, uranium-235 and uranium-238 are isotopes. Let's define nuclear reaction. It is a process that causes a transformation of at least one nuclei to another. We have two types of a nuclear reaction: spontaneous and provoked. The spontaneous nuclear reaction, like radioactivity, takes place without any external intervention, while the provoked nuclear reaction, like fission and fusion, occurs due to external intervention. The radioactivity is a spontaneous disintegration of unstable atomic nucleus called parent nucleus into more stable daughter nucleus with the emission of particles and radiation. An example is provided here. The carbon-14 is decayed into nitrogen-14 plus emission of an electron without any external intervention. The carbon is the parent nucleus and it is unstable and it is decayed without any external intervention into nitrogen-14, which is called the daughter nucleus. An electron is ejected during the decay. For this reason, this reaction is called radioactive nuclear reaction. So, the general equation of the radioactive nuclear reaction is as follows. We have an atom X is decayed without any external intervention into Y atom accompanied with emission with particle and radiation. Example: the uranium-238 is decayed into thorium nucleus accompanied with the helium particle and gamma as electromagnetic radiation. There are two types of radioactive reaction. It can be occurred in nature or artificially prepared in the labs. Now we discuss the Soddy's law or the law of conservation of mass and charge number. Here we have the general nuclear reaction of radioactivity. The equilibrium in this type of reaction should be done at the level of number of neutrons and protons, thus at the level of the charge number and the mass number. This equilibrium is formulated by Soddy's law or the law of conservation of mass number and the charge number. The mass number A of the reactant nucleus is equal to the sum of the mass number of both the daughter nucleus and the emitted particle. So we can say that A before is equal to A after, then A is equal to A prime plus B. In the same way, the atomic number Z of the parent nucleus is equal to the sum of the atomic number of both the daughter nucleus and the emitted particle. So Z before is equal to Z after, then Z is equal to Z prime plus A. We discuss in the following an example to explain the conservation of mass number and the charge number in a radioactive reaction. Initially, the phosphorus nucleus has a mass number A equals 30. After decay, we can see that the sum of the mass number of the product is 30 plus 0, so it is equal to 30. This indicates that the mass number is conserved. In the same way, for the charge number, we can see that we have 15 proton in the reactant, and it is equal to the sum of the proton of the product, since we have 14 protons within silicon atom plus 1 proton from the positron particle. The sum of 14 plus 1 is 15. This is also indicates that the charge number Z is conserved. Let's solve application 1. Consider the following nuclear reaction. C14 is decayed into nitrogen with mass number A plus particle. It may be electron or positron. In the first question, we have to determine the constituents of carbon 14. In other meaning, we have to determine the number of protons Z, the number of neutrons and the number of the nucleons or the mass number A. The mass number of the carbon 14 is A equal to 14 and the charge number Z is 6. Then this nucleus contains 6 protons. So the number of neutrons can be determined by the relation N equal A minus Z. I substitute the values and I get 8 neutrons. In the second question, we have to specify the type of this nuclear reaction. The answer of this question is very simple. This reaction is a radioactive nuclear reaction, since the carbon 14 decays onto nitrogen 14 accompanied with the emission of a particle without any external intervention. The last question asks us to determine A and Z using specific law. The specific law is Soddy's. From the conservation of mass number, we can calculate A. In the reactant, we have 14 nucleons, and in the product, we have A plus 0. So A is equal to 14. From the conservation of a charge number, we can calculate Z. In the reactant, we have 6 protons, and in the product, we have 7 plus Z. So Z is equal to 6 minus 7. It is equal to minus 1, which represent an electron of mass number 0 and the charge number minus 1. In the summary of this video, we have seen that the nuclear reaction can be provoked due to external intervention or spontaneous due to the absence of external intervention. The radioactivity is defined as the spontaneous decay of unstable nucleus into more stable nucleus with the emission of particle and radiation. The general equation of radioactive decay is given by X is decayed into Y plus emission of particle and radiation. Also, the radioactivity can be artificial or natural, and the last objective we have discussed in this video was Soddy's law, and it states that the mass number and the charge number are conserved. At the end, please watch carefully this video and for many times, and for sure don't hesitate to contact your teacher for any information about the first part of this chapter. Wassalamu alaikum wa rahmatullahi wa barakatuh.